Hi everyone and welcome back to the channel. In the previous episode we built the foundation of the state machine for our Sly Cooper game. Today we are going to refactor our current player code and move the relevant logic into appropriate states. Let's start with implementing the idle state. First, in the enter function we will add the logic to play the idle animation. Since enter is called immediately when switching state, the idle animation will play right away. Next, we'll move over the logic that slows down the player movement speed. Unlike the earlier implementation, we'll no longer use a speed variable. Instead, we'll pass a constant speed value depending on the player current state. Once the idle logic has been moved over, we can simplify the main player script by removing the extracted code. Now, in the process function of the idle state, we'll add the condition for switching from idle to walk. Let's move to the walk state. Just like before, in the enter function, we'll add the logic to play walk animation. In process, we'll add a condition for switching from walk back to idle. Then, in the main player script, we can remove the old code responsible for starting the walk animation. Since the movement logic will be used both in walk and run states, we'll create a general movement function in the player script. This function will be called in each state with the appropriate player speed value. To improve readability, we'll also move the logic for changing the player movement direction into a separate function and call it inside the input method. We will do the same for the camera rotation logic, moving it into its own function and calling it in input. This will make code more organized and easier to follow. Back in the walk state, in physics process, we'll now call the player movement function. Next, let's implement the run state. In enter, we'll add the logic to play the run animation. Then, we'll set up the condition to switch to idle or walk. In physics process, we'll call the same movement function just like for the walk. We will also go back to the walk state and add the condition to switch to run. In the main player script, we'll move the sprinting logic into its own function. After running the project, we should see the player correctly switch between states. Now, let's implement the jump state. Just like in the previous states, in enter we'll add the logic to play the jump animation. Then, we'll check whether the player should actually jump. Since both jumping and falling use the same animation, we'll keep them in a single jump state. In enter, we'll check if the jump input was triggered. If yes, the player will jump. If not, the player will start falling immediately. In process, we'll add a condition so that when the player lands, they switch back to the idle state. In physics process, we'll call the movement function so the player can still move in midair, and we'll also implement gravity. Now let's back to the main player script. We can now completely remove the physics process function. Next, in every player state, we'll add the logic for switching to the jump state. We will do this in two cases, when there is no ground under the player and when the jump input is pressed. Now, when we run the project, we can see that the player correctly switching between all states. Also, the issue when the falling animation wouldn't trigger has been now fixed thanks to the state machine. Okay, in this episode, we finished refactoring the player code into a state machine. If you enjoyed this episode, don't forget to leave a like, comment and subscribe. It's really helped me to stay motivated to keep making more content. Thanks for watching and see you in the next one.